All right, hello. Today we're going to be doing another problem. Is find first and last position of element in sorted array. That is a mouthful. Um, Basically we want to see if we can find the first and last um indices of which the number exists in the array. Um, and well, we want to do an O of log n complexity, as you can see from the question right here. Because realistically speaking, you could just go straight through the array, find the first index, and then find the last index, and that would be O of n times complexity, which realistically isn't that bad until you realize that this could be done in O of log n, which is much better than just O of n. And basically, if you don't find the number, you want to return -1, -1. So we're going to do, we're going to start a solution now. So we're going to write our result array, which initializes with -1, -1, because if we don't find it, we will just end up returning this, right? Well, I'm going to create a variable called left index where we're going to call a binary search function that I will write right after. We're going to pass in nums, target, and false. You know what? I'm gonna write this later because it probably won't make that too much sense right now. But basically, we have we start our result array and we're gonna return it at the very end. Pretty basic, right? We're gonna define our binary search function, which is just called binary because I'm too lazy to type something very long. We're gonna pass in nums, which is just a list of integers like we see above, right? We're gonna have target, which is also an integer, that we see above, and we're gonna have something called find max, which is a boolean, where this is going to end up returning an int, and then that is the method header of our function. The reason why we have find max is because assuming we do find the number, we need to decide whether or not we want to find the first index, which is the leftmost index, or the rightmost index, or I guess in the case of this question, the starting and ending position of the given target value. So that's what we're going to be using this boolean for. So we're going to be coding our binary search as we normally do. We start from 0 and then we get the length of nums -1. And we're going to have another item called key index, which starts at -1. This key index is going to tell us what index we have found for the number, and if we don't find it, it'll return -1, right? So what we'll do here is while left is less than or equal to right, like all of our binary searches so far, mid is equal to left plus right minus left. Whoa, the double register is real on this keyboard. So to explain again, we have our left index and we do right minus left, and then we floor division that, because if we were to do something like left plus right floor division, this could potentially overflow, but the way we do it like this, it'll be a much smaller number, and if we were to overflow from right in the first place, we would have overflowed here, so this should not be a problem. And so we're going to do the simple binary search if nums mid is less than target. Then we're going to move left over to the right side of mid. Else if nums mid is greater than target, we're going to do right is equal to mid -1. And our else statement is just nums mid is equal to target, right? We're going to do key index is equal to mid because we found the number, right? And if find max is true, then we want to move toward the right because we want to see the largest index where we can find this number, right? So we'll do left is equal to mid +1, and else let me actually write this here. So find max, so we want to find rightmost index with the number, And then here we want to find leftmost index with the number. And so here would just be right is equal to mid minus 1 because we want to go toward the left, right? And eventually this will converge and we'll break this condition, and so we'll return key index, right? So now going back up here, we're going to do left index is equal to self dot binary nums target, and we're going to do false because we want to find the left index, right? And so if left index does not equal to -1, right, which means we found the number, we will do result is equal to left index, and then actually no, because it might look a bit confusing for some people, we'll do right index is equal to self.binary nums target and true, and then result is equal to left index right index. And then so we'll just return result, and if it is equal to -1, that means we couldn't find it in our array, and so we'll just return the original result, which is -1 -1. And just to show you what I was going to write earlier, I was going to do result is equal to left index and then self.binary nums target and true. So it basically just replaces this variable right here. And this, how it does work, however, I understand how sometimes it could look, how it could look confusing for some people. So I'll just, pull it out here, and then we'll put result and then just set the array there, and then we'll do return result like that. And so this should work. If we submit, boom, it does work. So yeah, with that being said, thank you for watching.